In this video, I will demonstrate how to use the Select Best Data Points module of Magellan's Compass software. Again, Compass is running on a server and I access it through the Chrome browser. In the prior two videos in this series, I demonstrated how to select the data for initial analysis in the Parse Example subset module, as well as how to provide Compass with a dictionary file in the Molecular Dictionary module. We are now ready to extract the MS Level 1 information that is connected to user-defined biological differences between groups of examples. To do so, there are two user-defined parameters. First, the user can select the best algorithm for determining the decision value for each data point. The second, the user indicates the number of highest decision value data points to be returned for an initial analysis. Importantly, you can use the internal help bubbles provided for support and direction. Understanding decision values is important for working with Compass. Decision values are a measure of how well the abundance values across all examples for a single data point differ across the outcomes set by the user. In other words, decision values define how well a data point's pattern of abundance values across the set of examples under study can be used to predict an example's outcome classification. Different decision value algorithms are optimized for different types of data comparison. The two-way comparison is best for finding data points whose abundance values are markedly elevated in one group. The three-way comparison works for comparisons of one subgroup against the combined data from many other subgroups, as used in the each against others comparison. It also works against comparisons versus a mixed population. This is because the subgroup may contain data points whose values fall between lower and higher scores in the larger mixed population. Here I am working with a proteomics dataset derived from the NCI 60 panel of cancer cell lines, with many replicates for each cell line under study. This data is published and publicly available in the PRIDE data repository. In this project, I am comparing the results from each blood cancer cell line to all of the other blood cancer cell lines. Once run, the results can be presented for each pairwise comparison performed and visualized by a simple click. First presented are the ranked decision value scores for the best performing data points. There are several other visualizations that allow users to see how these data points behave during mass spectrometry. Each data point's position in retention time and M/Z dimensions is shown. Mean abundance and decision value scores are also plotted for each data point along either the M/Z or retention time axes. These data outputs are presented separately for each different mass spec preparation performed. Here, a single proteomics sample from each example was subjected to mass spec, generating a single file per example. If additional analyses of each example had been performed, metabolomics or another distinct proteomics analysis, say, the data extracted from those files would be shown separately. These plots are highly interactive. The user can select a single data point from any of the individual plots, and it will become highlighted across all others. Additionally, the abundance scores of the selected data point are plotted for each example and across all outcome categories, showing the trend in the individual abundance values within that data point. The user can drop down the numerical abundance values as well. Further, A mouse drag can be used to select a specific region of interest on any plot, which region's data points will be presented across the other plots. This allows the user to restrict visualization to data points in certain regions of the mass spec image or to those in abundance or decision value ranges selected. The axes along each plot allow the user to further refine the region under analysis, as well as to return to a view of the entire data point set. In the data set I am using here, I have not provided a dictionary file with MS Level 2 information. In another project where it has been provided, note that any data point extracted in this module that has an association with Level 2 MS information becomes highlighted. And when viewing abundance values within such a data point, the MS Level 2 identifier information from the dictionary file is reported below the plot. The function of this module is to identify information that is connected with biological differences under study, the outcomes, and view the behavior of the underlying data during mass spectrometry. Up next, I will demonstrate the use of the Random Outcome Check module, which module will provide the user with confidence that their extracted information is real and not an overinterpretation of random noise in a large data set.